Hey guys, I hope we're all doing really well. I'm really excited again. We have another milestone lecture as we enter the last unit of the semester, so Unit 6. So, for all of you who have stuck around this long and have seen every lecture, good job. I really hope you're doing this well in all your other classes, and I wish you the best. However, it's not over yet, so we still have a decent amount of information to go over. And in this unit, we're going to be focusing on pollution. And we're going to focus on pollution within the United States. And we're going to focus in this lecture on pollution throughout the mid 1900s. So we'll focus on what events catalyzed the government to actually step in and set rules and regulations. So we'll learn about what catalyzed the government's involvement. So in this lecture, we're focusing on, the early and mid 1900s and events that led to, the reduction of ecosystems and the reduction of species in our country. But next lecture, we're going to focus on more recent events, like in Flint, Michigan, for example. So there is pollutants still making their way into cities to this day. So really interesting and imperative unit for us to realize that pollution and how it has affected the past and how it's still interacting with the present day. So the first part of the lecture, we're going to focus on one chemical. That chemical you're going to know as DDT. DDT has a very long chemical name. No, I'm not going to try and read this out to you. We're going to know it as DDT. And this is the chemical composition of DDT. It was discovered in 1939 by a Swiss chemist named Paul Hermann Mueller. And it was used in the second half of the World War II as a defense against malaria. So to control the insects that vector malaria, as well as typhus. Because of this, he saved many people, and he was awarded the Nobel Prize in Physiology or Medicine because of this molecule actually efficiently reducing arthropods that, again, vector these diseases. So he was awarded that in 1948. We get to see what the chemical actually looks like. And there was a premature celebration, right? Yay, we found this amazing insecticide. People will not be affected as much by insects that are vectoring diseases. And I put this picture on to remind you, because again, our final exam is coming up, which is cumulative. This gentleman you should know as Norman Borlaug, and you should understand that he came around at this time and he was trying to increase crop yields everywhere. So DDT arises and, it reduces the herbivory by many arthropods feeding on crops. So just wanted to, reiterate some past knowledge. We have Norman Borlaug here, who again was very active during this time implementing ways to increase crop yield. Insecticides greatly increased crop yield, but there is a negative side to using insecticides that people at this time did not fathom, right? So it took decades for us to better understand chemicals, and these people leading the way, unfortunately, through trial and error, we do get these regulations in place. But in October 1945, DDT was actually available to the public. So you can go to like Home Depot. I don't know if Home Depot was around back then, but these home stores, and you could buy this really, strong chemical deterrent and you just put it on your garden if you wanted to reduce herbivory of your garden, for example. So in 1945, it was publicly available, and it was actually promoted by the government for the use of agricultural and household pesticides. So nobody thought anything of it. You can see this is actually an old container, and it has 50% DDT. You see the patent number, and it is a broad range insecticide, so it reduces many different insects. So to the consumer, this is really good. It's kind of a one-stop shop. Oh, like I don't even know what kind of bug is infesting my tomato plants, but DDT has a wide niche of killing insects, right? It's not very specific. So that's like good for the everyday person who doesn't understand, ecology, for example. But you scale this up into a huge agricultural system, and you have acres and acres of land getting sprayed with DDT. This broad range insecticide, it turns kind of dark, because you're killing many insects that might be beneficial, right? And this isn't even the focus on DDT. Yeah, we're going to touch on that in a few slides, but we're going to learn about a really, kind of scary underlying theme with pollutants that make their way into ecosystems. But before we get there, around this time, so 10 years after DDT becomes available at your local, home store, the World Health Organization, they commence a program, a worldwide program to eradicate malaria. So this relies on killing mosquitoes, because mosquitoes vector malaria. Malaria, in the next slide you will see, is a protozoa. So it's a little tiny one-cell organism, and it carries out its life cycle, and you get sick, and in many places malaria still occurs today. But DDT, it actually did do a really good job in eliminating the disease in North America, Europe, the former Soviet Union, Taiwan, much of the Caribbean, the Balkans, parts of North Africa, the northern region of Australia, and a large swath of the South Pacific. It also dramatically reduced mortality in Sri Lanka and India. So another, huge positive. Yes, it's reducing herbivory in crops, but it's also really reducing the spread of this really harmful disease that is vectored by mosquitoes. So again, malaria is a mosquito-borne infectious disease affecting humans and other animals, which is caused by a parasitic protozoan. So again, this is a tiny little one-celled organism that carries out this complex life cycle, and it is vectored actually through the salivary glands in the mosquitoes. So female mosquitoes are the only mosquitoes that actually bite humans, because females, they need a rich protein diet to produce eggs. Males, they can feed on nectar, and they don't have to live the dangerous life of actually feeding on a warm-blooded mammal. So the actual part of the malaria protozoa is kind of laying and resting in its salivary glands. Female mosquitoes will inject their saliva into their host as a anticoagulant, so they can feed on blood more efficiently. Now, when they expel their saliva, they also expel malaria if they, again, are infected with this protozoa. The life cycle of the malaria parasite kind of looks like this. So where do we start? Let's start at 1. So this is actually where the female mosquito injects the sporozoites through its saliva into the human. So the red signifies the life cycle within the human, and then the white signifies the life cycle within the mosquito. So many parasites, they use multiple hosts like this. So through the saliva, those almost boomerang shaped sporozoites, they actually penetrate the human liver cells, where they proliferate and turn into merozoites. The merozoites are expelled through liver cells, and then why it's so hard to control malaria once you're infected is because those merozoites, they actually penetrate red blood cells. So your own immune system, it can't actually detect the merozoites because it's being held within your red blood cells. So your red blood cells can actually carry out, their function, delivering oxygen throughout your body, and still having this parasite within it, where they too are proliferating. Then you have the sexual stage, where male and female gametocytes form, and then another mosquito that might feed on you will actually, inject its proboscis and feed on blood and actually get infected by these female and male gametocytes. You get sexual reproduction, and then you get this life cycle continue again. So in 2016, there was actually 216 million cases of malaria worldwide, which is estimated at more than, it's a ridiculous number. It's almost, a billion deaths, right? So 731 million deaths. And you can see that malaria, it is much more prevalent near the equator. So that makes a lot of sense. And when you start to realize there are some ecological patterns. So warmer and wet areas where, malaria and where mosquitoes really thrive, and their offspring, their aquatic offspring, can really thrive right along the equator. Right? In northern and southern latitudes, it gets much cooler. There's much less available water. And it's near the equator that their life cycle is actually year round. Whereas where we live, there's no mosquitoes. I'm literally looking outside. It's snowing. There's no mosquitoes here now. So there is this seasonality that is near the equator. These life cycles are maintained throughout the entire year. Now, deaths due to malaria per million persons, you can see that throughout Africa and Central Africa, it is a really big issue, still very prevalent. And it's just sad because depending on the socioeconomic status of a country, if there's less infrastructure and less money towards, medical expenses, there's going to be larger malarian outbreaks. And just a little backstory. I think this is really cool. Just recently, they found a mosquito that had, a full belly full of blood, and this was dated to 25 million years ago. This was found in Dominican amber, and they actually saw the Malarian oocysts. So malaria was prevalent even 25 million years ago. Some Jurassic Park vibes there. Great movie. So this DDT promise did come up short for more than one reason. Firstly, there was a failure to sustain the program. Any worldwide program to reduce a global disease requires a lot of effort on the ground, and they're just simply really hard to sustain for years and years. Additionally, the mosquitoes acquired more of a tolerance or a resistance to DDT, as in every generation there were certain individuals that weren't as compromised when they encountered these DDT molecules, and it's those individuals that were more efficient at reproducing, and they passed their genes. So, there's more and more resistance as time progresses towards DDT. Now, the program did succeed in eliminating malaria in areas with high socioeconomic status. These places also have well-organized healthcare systems and relatively less intensive or seasonal malaria transmissions. DDT was less effective in controlling malaria in places near the tropics, where the life cycle of mosquitoes is year-round. There's no seasonality. They're just continuously, breeding and growing and infecting. And it's also many of these places that, too, have very poor infrastructure. Now, there was an initial resistance to DDT, not like chemical resistance, but like social resistance, as some researchers kind of spoke their mind and said, hey, like, you can't just be spraying this stuff everywhere. We don't know enough about it. In the mid 40s, some scientists questioned the pesticide, as it would probably kill beneficial pollinators. Many crops that we utilize still require pollination. So how is this DDT molecule that is a broad range pesticide going to not kill beneficial insects? In 1947, Dr. Bradbury Robinson, who was a physician and nutritionist practicing in St. Louis, Michigan, he warned us of the dangers using DDT in agriculture. He understood that biota, outside of just this plot of land that is being grown, cultivated to feed humans, that there are neighboring wild ecosystems, and that spraying a pesticide here, some of those chemicals will move over and be through wind, be carried over and change the biota of nearby ecosystems, both directly and indirectly. So he understood more so the implications of using this really noxic pesticide. Moving on to the environmental impact. DDT is a persistent organic pollutant that is readily absorbed by soils and sediments. So these soils and sediments can act both as sinks and as long-term sources of exposure affecting organisms. So these DDT actually can stay in an ecosystem for several years. So depending on the conditions and its soil half-life, the chemical actually can exist from 22 days all the way to 30 years. So a pesticide that does not break down for 30 years, that's rather alarming. And when it does break down, it breaks down into these products and metabolites known as DDE and DDD. And these are also very persistent and have similar chemical and physical properties as well. So just by the chemical DDT breaking down, it doesn't break down into a non-harmful substance. It still actually is quite harmful, which we will get into next. In aquatic ecosystems, DDT and its metabolites are absorbed readily by aquatic organisms because they work their way onto suspended particles. Those particles, tiny animals eat those particles, and larger animals eat those tiny animals, and it radiates up these food webs. So eventually DDT works its way into living organisms. So after a long enough time, there is little DDT dissolved in the water. Now, this might sound good. There's no DDT in the water. It's all in animals. But that's not good, right? Because animals are living and you are changing, many different interactions by having this chemical in all of these animals. So, two really important red terms. These are imperative, and I love teaching about these. We have bioaccumulation and biomagnification. Bioaccumulation explains that certain toxins, they are readily absorbed into an organism's body. So where there is high levels of DDT, there's going to be higher levels of DDT in living organisms than in the environment. So this has to do with the chemical properties of whatever substance you're looking at, and DDT happens to be readily bioaccumulated. So again, DDT works its way into living organisms quite readily. Now, biomagnification explains how these toxins become more and more concentrated with increasing trophic level. So the higher you go up in the trophic level, remember you have producers, you have herbivores, you have predators, you have secondary predators, and tertiary predators. Those tertiary predators, they're going to have the highest amounts of DDT in them. So that is an example of biomagnification. So here we can see these two figures, and I like them both. They are actually saying much of the same thing. They're just kind of depicted a little bit differently. So let's start on the right here. You have DDT in the water, which is 0.000003 parts per million, or 3 parts per trillion, right? So very, very low concentrations. But you have the zooplankton that are, feeding on plankton, right? And it actually skips a trophic level. So you have water, which isn't a trophic level, but you should have phytoplankton, plants, right? So here you have plankton that work DDT and absorb DDT and fix it into its own sugars, and especially the DDT actually attaches to fat molecules within plants. Next, you have zooplankton eating those plants, those algae, right? And their concentration of DDT is much higher, right? Because they are eating a lot of these plants, right? As you go up another trophic level, you have these minnows, you have 0.5 parts per million of DDT in their tissue. So again, much, much higher levels of DDT. This DDT is definitely accumulating. Think about all the zooplankton these minnows have to feed on, right? That's why you have this accumulation. Then you have these large needlefish, these predatory fish that are eating many minnows, right? So again, you have this leap in DDT concentration. Finally, you get the top predator, this osprey, these predatory birds, these tertiary predators. And they eat several fish a day, right? So they're selecting large fish that have the most DDT in the aquatic systems, and they're eating several of them a day. Remember, birds have the highest metabolism on the planet. They need to feed an extraordinarily high amount of food, right? So because they're eating all these predatory fish, if you actually take a blood sample or a tissue sample, you can clearly see that birds of prey have the highest levels of DDT in their tissues. Now, why I like both of these is because you can see how DDT creeps up from water to phytoplankton to zooplankton to small fish to fish eating birds, right? You can see how that is. I like how that's represented, and I also like how the magnification of DDT looks like in this arrow, right? And you could see these exponents greatly showing the orders of magnitude of biomagnification, right? But also why I really like this one is that there is this volume, right? So clearly there's a lot more water than there is phytoplankton, and there's a lot more phytoplankton than there are zooplankton. So basically these bars show, the biomass of each trophic level. There's not a lot of biomass as you get up to this bald eagle, right? However, there is a significant increase in the DDT you find in their tissues. So I really like both of these figures. I think they're, imperative to realize what's going on in these systems and that have to do with pollution. So why does DDT and many other toxins do this? Well, if a molecule has an affinity for fat, which is another term, lipophilic properties, fat-loving properties, then fat is something that we store, that all animals throughout the animal kingdom, they store fat as this energy reservoir. So DDT is stored in fat, and animals store fat for in case of emergencies. Evolutionarily, there are hardships that occur in ecosystems, and organisms might have to tap into their fat reserves, but they usually don't. So DDT is stored just as fat is stored without being fully utilized. So again, these are reservoirs for DDT. Now, this is when we have, this is the moment in which the U.S. government gets involved as DDT greatly reduces our nation's mascot, the bald eagle. So DDT and the breakdown, as it breaks down, remember it turns into DDE and DDD. These chemicals cause eggshell thinning. So for whatever reason, this molecule, there are these glands that there are these specialized physiological structures that filter calcium out of the bird's blood and takes that calcium and forms a eggshell. These molecules, they stop that physiological process. Whatever molecules or channels are filtering calcium out of the bird's blood, those get blocked up, and the birds can no longer synthesize a thick shell. If a bird doesn't have a thick shell, the embryo will not develop. It'll be too fragile. You'll get bacteria, breaking in and consuming the developing embryo, etc. So, again, there's strong evidence, and researchers have actually found out that actually DDE inhibits calcium APTase in the membrane of the eggshell gland and reduces the transport of calcium carbonate from the blood into the eggshell gland. So looking at these pictures, what can you tell me about these birds? Well, These birds are predators. They're pescivorous, right? Piscivorous, they're eating a lot of fish, right? So it's these birds that were hit heavily. And I love this graph so much. You have eggshell thickness as a function of time up until 1945, right when DDT becomes available to the public. You get this sharp reduction of eggshell thickness, right? And it takes until the 70s for the U.S. government to get involved to stop DDT from being sold commercially. And you get this wide breadth of eggshell thickness once, there are regulations in place. So I really like to see, boom, right when it becomes available, you see this sharp decline in eggshell thickness. So this is a great example of the power of certain species, right? When a charismatic species like the bald eagle becomes reduced, people take notice, right? Opposition to DDT was focused by the 1962 publication of Rachel Carson's book, Silent Spring. If you are into conservation, if you're into environmental biology, this is a must read. It cataloged environmental impacts that coincided with the widespread use of DDT in agriculture within the United States. And it questioned the logic of broadcasting potentially dangerous chemicals into the environment with little prior investigation of their environment and health effects, right? So before this, hey, this chemical reduces insects, let's spray it everywhere. After this, what interactions are going to occur, right? But I have this slide up to talk about something important, which is these charismatic species. People respond to charismatic species, but animals are going extinct all day. The panda will never go extinct because people love pandas. However, there's an insect that I've never heard about that just went extinct, right? And that's important. That's an important, idea of conservation. How do you get everybody involved to protect all species? Not only the charismatic species should be saved. All species, we should attempt to save all species, right? Clearly, there are some species that are on the brink of extinction, and nobody even knows about them because they're not charismatic. And this is, this highlights how fast you had this, how fast the government got involved once our bald eagle was threatened, right? So this is what Silent Spring and the author looks like here, Rachel Carson. The book claimed that DDT and other pesticides have been shown to cause cancer, and their agriculture was a threat to wildlife, particularly birds. Its publication was a seminal event for the environmental movement and resulted in a large public outcry. Remember last lecture I talked about public opinion and how important that is, and why it's important even after you're done with this course to understand and read articles that have to do with what's going on in the planet, what's going on with the environment, because it's young educated people that can cause a public outcry and change the public's opinion, which then influences governments for taking action. Eventually, in 1972, DDT was banned for agricultural use in the United States. So in a relatively short period, right, you get the ban of DDT. And in 1973, there's not many acts I have you remember, but this is one of them, the Endangered Species Act of 1973. Now, this act was designed to protect critically imperiled species from extinction as a consequence of economic growth and development, untampered by adequate concern and conservation, right? So a species extinction that has been catalyzed by our economic growth must be addressed immediately. The ESA was signed into law by President Richard Nixon in 1973 on December 28th. The U.S. Supreme Court found that the plain intent of Congress in enacting the Endangered Species Act was to halt and reverse the trend towards species extinction at whatever cost. So, success story there. DDT was banned, and people start to understand these species interactions and how humans interact with their environment. Another chemical that I want you to watch this video, it's on PCBs. Basically, General Electric took a PCB dump in the Hudson River, and this impacted the sediments, the water, fish, and air. PCB was a fire retardant, and it's, if you actually, travel to New York City and you travel up the Hudson River Valley, these multi-million-dollar homes are there. And unfortunately, still to this day, because of these PCBs, it's these really, really wealthy families have some of the highest rates of cancer in all of New York. So that is contrary. Usually people in poor housing, poor development housing with little access to fresh fruits and vegetables and in some cases clean water. It's usually poorer communities that have higher rates of cancer. Here, because of General Electric's actions, you have this opposite idea. So definitely check out that video. I'll put that as link number 1 in the description below. Another red term is a Superfund site. So a Superfund site is a toxic waste site identified by the federal government that could harm human life and the environment, right? So look at all these Superfund sites and look at the East Coast, right? And we actually have some right in our own backyard. This highlights actually the Rust Belt, right? These regions were extremely important for trading in the early 1900s, as the Great Lakes were utilized to transport a bunch of materials. And then you have the Erie Canal. You can see along the Erie Canal, you have all these Superfund sites. But I mean, really, the East Coast is just, New Jersey, Connecticut, all these really crazy Superfund sites. Not Superfund, Superfund, right? And it highlights the economic past of these places. So I want to focus on one Superfund site that is very close. It's about 15 minutes away if you're living on campus or you're living in Buffalo. We have Love Canal, right? So here we have, 1300 Elmwood, Buffalo State College, right around here. And cross the Grand Island Bridge and get into Niagara Falls. You make a quick right on LaSalle Expressway, and here you have a Superfund site, Love Canal. So Love Canal is a 70-acre landfill that served as an epicenter of a massive environmental pollution disaster that affected the health of hundreds of residents. This was once a residential area, and this really, large chemical company known as Hooker Chemical Company bought the property and started dumping massive amounts of toxic wastes on the ground. at least they would bury them, I guess. But for 10 years, you have this Hooker Chemical Company that eventually dumps 21,800 tons of chemical byproducts from manufacturing dyes, perfumes, and solvents for rubber and synthetic resins. These chemical constituents include caustics, alkalines, fatty acids, and chlorinated hydrocarbons. So just 10 years of dumping chemicals, what that can do to a region. So the lead up to the discovery, residents, they were suspicious of black fluid that flowed out of the Love Canal. For years, residents complained about odors and substance on their yards or the public playgrounds. So their kids were playing in toxic sludge pretty much. Finally, the city acted and hired a consultant, the Calspin Corporation, to do a massive study. Next, the blizzard of 77. So my mom tells me stories about the blizzard of 77. The blizzard of 77 rolled in, leaving 33 to 45 inches of snow. And as this snow melted in the spring, you actually get the water table rise. And when the water table rose, you have this excess water that contained all these chemical byproducts literally being ejected and erupted out of people's backyards. So black sludge was literally erupting like a geyser in some people's backyard. So here are some pictures of the blizzard of 77. I think these are pretty cool. And it didn't snow that much, but wind actually pushed huge mounds of snow over certain structures. In the spring of 1977, the state's Departments of Health and Environmental Conservation launched an intensive air, soil, and groundwater sampling and analysis program following the qualitative identification of a number of organic compounds in the basement of 11 homes adjacent to the Love Canal. So they found all these organic compounds that leached into people's basements. This event displaced numerous families, leaving them with long-standing health issues and symptoms of white blood cell counts and leukemia. All right, so many people got sick. And actually, my student last year, she showed me this picture. This was actually her dad. So I thought that was really crazy. So I'm glad, a student of mine sent this to me. So if you have any pictures about Love Canal or, the blizzard of 77, send them to me. Now, obviously, this is uninhabitable even today. The amounts of hydrocarbons and other pollutants that many of them are, lipophilic and will work into and latch onto fat molecules and will be in your body for a really long time and can alter the physiology of many functions within your body. So what did we learn from this? Well, basically, and what you will also find out is that dumping pollutants is cheap. And if you do it in an isolated manner, nobody, will bother you, because it does generally take, if you select a spot to dump these pollutants, it will take years for people to kind of take notice. Up until that time that people eventually take notice, your company might have already grossed millions and millions of dollars and be willing to pay those repercussions. So unfortunately, money does lead this. It's super cheap. It's free to dump these pollutants, whereas it is extremely expensive to transport these these chemicals and to treat them in facilities. And I just wanted to bring this up to you. This happens in America. This happened in America, right? So think about like third world countries. There are places on this planet that would do anything for just a little money, and they are importing people's toxic compounds and saying they have facilities to treat them, but really they're just dumping them. And it's scary because there are compounds that last several years, decades, right? And those eventually, if they don't harm us, they will interact with the local biome, right? The biome that is neighboring these sites. So I just wanted to introduce pollution in the 1900s and give you some relevant scenarios that I found really important. Thank you for your attention. Again, make sure you are happy, healthy, both physically and mentally, and I will catch up with you guys later. Bye, guys.